Right guys, in this video we're going to be looking at simplifying fractions. When we're trying to add or subtract fractions, the easiest thing to remember is we need a common denominator. If it was a nice normal sum like 1 over 2 plus 3 over 5, 2 times 5 gives me 10. So I know my common denominator can be 10. But if I want to change the bottom to 10, I need to do to the bottom what I do to the top. So I timed 2 by 5 to get 10, so now I need to times the top. So 1 times 5 gives me 5 over 10. 5 times 2 gives me 10, so now I need to times the top. 3 times 2 gives me 6, which means now I can add the tops, which is 11 over 10. Okay? The same way now, I need to get a common denominator here. But just like I used 2 and 5 to get 10, I'm just going to multiply my two bases, my two denominators, to give me a common denominator of 3x minus 1 by x plus 3. But remember, what you do to the bottom, you have to do to the top. So if I multiplied 3x minus 1 by x plus 3, I now need to multiply the top, which was 5, by x plus 3. If I multiplied x plus 3 by 3x minus 1, I now need to multiply the top, which was minus 2, because of the minus in between, by 3x minus 1. Some people also call this cross multiplying. Okay? So now I multiply at the top. 5 by x is 5x, 5 by 3 is 15, minus 2 by 3x is minus 6x, and minus 2 by minus 1 is plus 2. All over 3x minus 1 by x plus 3. And I'm not going to multiply at the bottom because I'm keeping it as my common denominator. So now I add my like terms, so 5x minus 6x is minus 1x, 15 plus 2 is 17, all over 3x minus 1 by x plus 3. Okay? And that's my sum done. Now, when I look at the second one here, I have x minus 4 over x squared minus x minus 2, x minus 3 over x squared minus 4. So straight away I'd see on the bottom, I can't just combine these two because that's going to make my multiplying very long. But I have a quadratic on the bottom here and difference of two squares here. So before I start adding or subtracting, I'm going to factorize, which would leave me with x minus 4 over two sets of brackets with an x in each bracket. My only factors of 2 are 2 and 1. And if I want to get minus 1, I'm going to need a minus 2 and a plus 1, which is what I have here. Minus x minus 3 over. If I have difference of two squares, I square x to get x squared, and I square 2 to get 4. So I'm going to have x minus 2 and x plus 2. So what I can see now is that minus 2 and minus 2, these brackets are the same. So to get a common denominator, I don't need 4 of them, I only need 3. I have x plus 1 by x minus 2 by x plus 2. Okay? Which means now I can actually see that again here, to do this one, I only need to multiply by the one that's missing. So this one has x plus 1 and x minus 2, so it's only missing x plus 2. So I'm going to have x minus 4 by x plus 2 minus, and here I'm going to have x minus 3 by x plus 1, because x plus 1 was the only one missing on the bottom. So now I'm going to multiply out the brackets. So I have x by x plus 2 minus 4 by x plus 2 minus x by x plus 1 minus 3 by x plus 1. You'll notice I've left a giant bracket out here, even though it got a little bit squishy, because that minus has to be multiplied in at the end. And on the bottom, guys, I'm still just going to leave it as x plus 1 by x minus 2 by x plus 2. So now when I do this one, you're okay. Now when I do this one, I'm just going to multiply at the top. So I have x by x is x squared, x by 2 is 2x, keep going, minus 4x minus 8, minus by x squared plus x minus 3x minus 3, all over x plus 1 by x minus 2, which you can't see on the screen, x minus 2 by x plus 2. Okay? So now I'd see this minus out here is going to change this guy to a minus, this guy to a minus, this guy to a plus, and this guy to a plus, because a minus by a minus is a plus. So that means I have x squared minus x squared, which means they cancel. 2x minus 4x gives me minus 2x. Minus x gives me minus 3x. Plus 3 means they cancel. which means I'm left with minus 8 plus 3, which just leaves me with minus 5. So my final answer here is minus 5 all over x plus 1 by x minus 2 by x plus 2. And if I wanted to go one step further, guys, I can see that these two brackets together go back into being a difference of 2 squares, which means I could actually factorize them again and have minus 5 over x plus 1 by x squared minus 4. But you could have just left it here. Okay? Now, guys, we're going to do one more example, which is where we have one of the more complicated looking fractions, but it's actually quite straightforward. Now, the way I do these sums, guys, to simplify, I look at them as two separate ones. I look at them as the top and I look at them as the bottom. Okay? So if I look at the top first of all, okay, so the top is y minus x squared plus y squared all over y, which I'm going to put y over 1, okay, which means my common denominator here is really going to be y, which means I need to multiply the top of this guy by y. So I have y by y minus x squared minus y squared. So they both become a minus because the minus applies to both of them, which means I have y squared minus x squared minus y squared all over y. So my y squared minus y squared cancel, so I'm left with minus x squared over y, and that's the top. Then I'm going to look at the bottom. Okay, when I look at the bottom, I have 1 over x minus 1 over y, okay, which means my common denominator is going to be xy. So this guy was missing the y, so I'm going to multiply the 1 on top by y. This guy was missing the x, so I'm going to multiply the 1 on top by the x, which means I have y minus x over xy, which is now my bottom. Okay, that means I go back to the very top and I sub in my new fractions. So I have minus x squared over y all over y minus x over xy. Now the way I divide using fractions is I actually take the bottom, I flip it, and I change it to multiply. So now I have minus x squared over y times xy over y minus x. So I can see my y's and my y cancel. I have minus x squared times x, which gives me minus x cubed, all over y minus x. And this, lovelies, is my final answer. And we're done.